Maybe the damn thing is flat. Damn it! So a few days ago I did an observation making a sundial on my patio, and I remember all the globe believers told me the shadows move across the ground in a straight line. That's how you know you're on a globe. So I marked it and measured it. Wait a minute, something doesn't look right. That's not straight. So I do a little further testing. I make a smaller scale of what I observed on the patio, and I also made some shadow observations on my globe. So we'll mark that shadow, and then we'll turn it a little bit further into the day. Mark that shadow right there. So as you can see, that shadow is following that arcing pattern. So as I hold a straight edge piece of paper over this, it is making an arc away from the paper, coming back to the paper, which is what we saw when we marked the ground all the way up here to 5:50 in the evening. So that was our bigger scale. Here's our smaller scale. We can even mark it again. The sun has moved a little further. We can put a little mark where the shadow is. We can spin it around. Hard to hold it still and do it all at the same time. So even there, it's making the same pattern. So we have that pattern there, and that pattern there. Somebody didn't like that I used my phone for a compass, so there you go. There's an actual compass showing north, pointing that way. And also for the small scale one, north is that direction. Not as prominent as the large scale one, but you can still see that there is an arc. So now that I have marked this as how it behaves outside in a real world application, I can take my 3 light sources of equal height using the same type of LED bulb, daylight color. So we have our first shadow set. It's a little hard to see there while it's sitting still, but if we move it, you can see the shadow is right there. So way over there is our sun. We have our second shadow aligned. Right there is our sun for that one. Over there's the first one. And there's our last shadow, with the sun closer yet. So we have all 3 light sources equal height making the shadows on this box. Here's an overhead look at our 3 light sources, but I'm seeing a problem. These light sources are making a curve in the opposite direction of what we see in real life. That is north. If the sun is supposed to swing around us from the north, how is this the light source needed to make that curve? Now I was able to manipulate and move these lights around so that I could line up all 3 of my shadows and still get the proper arc for the sun to be swinging around our north pole. Just one problem though, I had to move the center light source way up high. So it's possible to do as long as our sun is doing a roller coaster heel every now and then. But I don't think I could make any more adjustments to make any of the other ones line up and it still stay in the same arc. That's just not what we observe in reality. So I think I'm going to stick to my guns and say that the Earth is a sphere. If the Earth was flat and the sun did spin around the North Pole, I have this string to hold my light equal distance from there. And my assistant will move around the room. I'm going to mark it right here. All right. Pause. All right, move on around. Pause. Oops. Move on around. Pause. Move on around. Pause. Alright, so that is what we would expect to see. Oops, I missed a shadow right there. That is what we would expect to see around our point of the shadow if the sun is arcing around the North Pole. And this time of year, the sun is about its furthest point from the North Pole. So in our summer months, when the shadow is almost directly overhead and the sun is swinging around the north that way, we could expect this shadow to basically go all the way around our point that's making the shadow. So if the sun was swinging around the North Pole, that shadow is always arcing around the object creating the shadow. And in reality, what we observe is the shadow is actually arcing this way. All is well again. What? I said I was sorry.